In the previous video, we presented the epsilon delta definition of the limit of a function. This definition is relevant when the plot of a function vertically approaches a particular finite height while horizontally approaching a particular value of x. In this video, we define improper limits, which can be used to analyze functions that become arbitrarily large. This notation reads, the limit as x approaches a of f of x is positive infinity, roughly meaning that as x becomes arbitrarily close to a, f of x becomes arbitrarily large. We translate these mathematical symbols into an unpacked English description, which reads, for all positive m there exists a positive delta such that confining x to be between a minus delta and between a and a plus delta implies that f on x exceeds m. To more concretely illustrate this concept, we draw a function plot exhibiting a vertical asymptote. We use gold shading to denote a region above the line y equals m. The shading continues forever beyond the range that can be illustrated on this slide of finite size. We are able to identify a positive delta that specifies two blue intervals. The one on the left-hand side is between a minus delta and the one on the right-hand side is between a and a plus delta. Within these blue intervals of x values, the yellow curves are vertically confined to the golden region. For this larger value of m, we can identify a smaller delta that specifies narrower blue intervals within which the yellow curves continue to be guaranteed to remain vertically confined to the golden region above the golden dashed line. For this even larger value of m, we can identify an even smaller delta that specifies even narrower blue bands within which the yellow curves still remain vertically confined to the golden region above the golden dashed line. Consider the possibility that the process we have illustrated in these last couple of slides can be continued by investigating finite values of m that become large without restriction. Consider the possibility that no matter what m we investigate, there always exists a suitable finite delta to specify blue bands within which the yellow curves are ensured to be vertically confined to the golden region above the golden dashed line. If these possibilities are satisfied, then the limit as x approaches a of f of x in fact equals positive infinity. Now that we have explained what it means for a limit to equal positive infinity, it should be straightforward to define what it means for a limit to equal negative infinity. Please pause the video to write down the analogous vernacular, symbolic, and unpacked English definitions for the notation that is read, the limit as x approaches a of f on x is negative infinity. The limit definitions we have explored in this and the preceding video allow us to investigate the behavior of a function as we approach a particular value of x. The next video defines limits at infinity. Such limits allow us to describe the behavior of a function as x increases without bound, rather than as x becomes arbitrarily close to a particular finite value.